Drooling is inevitable. I mean, it will happen at least once in your life. As a little baby, you probably had an uncontrollable stream of saliva 24/7. Or maybe you drooled a little when you were dreaming about a tasty snack in a boring class when you were 12. Perhaps a little saliva ran down your chin when you were looking at a fancy car you couldn't afford. And of course we all know the tired parent who falls asleep 5 minutes into a flight and drools everywhere. But what's the culprit behind all these accidents? It's of course the salivary glands. Today we're looking at the parotid gland, or more specifically its microstructure, as we investigate its histology. We've already established what our topic is for the day, but let's take a deeper look at what we'll learn today. We'll have a recap of the gross anatomy, location and function of the parotid gland. We'll then look at the tissue or stroma of the parotid gland, including its capsule, interlobular septa, and how they divide the parotid gland into lobules. Next up, we'll look at the main functional unit of the parotid gland, known as the salivon, and the duct arrangement within it. Finally, we'll identify some structures housed in the connective tissue surrounding the parotid gland, and we'll finish up with some clinical notes. The parotid gland is the largest of the 3 major salivary glands. It is a paired exocrine gland, which releases serous secretions into the oral cavity. That means the secretions are watery and rich in enzymes, which play a role in digestion of carbohydrates. The gland is located subcutaneously in front of the ear and is roughly triangular in shape. It is divided into deep and superficial lobes. The secretions of the parotid gland drain into the oral cavity via the parotid duct, also known as the Stenson duct, which can be about 5 to 7 centimeters long. If you'd like to know more about the gross anatomy of the parotid gland, we have a whole article and a video dedicated to the parotid gland. Now that your memory is all refreshed, it's time we focus on our topic in question, the parotid gland histology. The parotid gland, just like the other major salivary glands, is covered by a thick, dense connective tissue capsule. The capsule sends extensions into the parenchyma of the parotid gland, forming interlobular septa. Within the septa, you'll find the larger blood vessels and excretory ducts, which we'll be talking about in a while. These septa divide the parotid gland into what is known as glandular lobules. Now let's take a closer look at what we'll find in these lobules. Essentially, all elements you'll see here are parts of a salivon, the functional unit of salivary glands. The first part of the salivon is a sac called the serous acinus. The acini in the parotid gland are roughly circular and form a branching pattern with the parotid ducts similar to a bunch of grapes. An acinus forms the secretory part of a salivon and is made of serous acinar cells. These serous cells are wedge-shaped, with a wide basal surface and a narrow apex, which faces the lumen. Most of the organelles are stored in the basal part of these cells. Due to the rough endoplasmic reticulum and free ribosomes, the basal part is stained with hematoxylin and comes up dark blue. The apical end is full of enzymes stored as zymogen granules, which are stained bright pink by eosin. However beautiful this staining would look in theory, in practice the cells are packed together so tightly that they come up looking purple, especially when viewed at low magnification. You'll easily identify serous cells in an H&E section because they stain so deeply, while the mucus cells found in other salivary glands are very pale in colour. Surrounding the acini and proximal parts of the duct system, which we'll discuss in a bit, you'll find myoepithelial cells. These are contractile cells found between the basal aspects of the serous secretory cells and the basal lamina. Through their contractile action, they help to propel the serous secretions into the duct system. In this histological slide, you can only identify the elongated nuclei of these cells, because the acini are so tightly packed, but you would be able to see them fully using electron microscopy. So all these secretions made by the serous acinar cells have to go somewhere, right? That's where the rest of our salivon comes in. The serous secretions are first up collected in an intercalated duct. These ducts are the smallest of the duct system and are easily identified by the cuboidal epithelium which lines them. Intercalated ducts don't just carry the serous secretions away from the acini, they also add bicarbonate ions to it and absorb chloride to regulate the chemical composition of the secretions. The secretions are then carried into larger striated ducts. They are lined with simple cuboidal epithelium closer to the intercalated ducts, which becomes columnar in the sections nearer to the excretory ducts. At higher magnification, you can see infoldings at the basal surface of the cell membrane, which appear as striations and in turn give the striated ducts their name. Just like intercalated ducts, striated ducts change the composition of serous secretions. They add bicarbonate and potassium ions to the mix and absorb sodium ions from it. The last part of a salivon is the excretory duct. It is the largest of the duct system, and you can identify it by the stratified cuboidal or pseudostratified columnar epithelium, which lines it. The excretory ducts are found embedded in the connective tissue septa, dividing the gland into lobules. There are numerous excretory ducts of varying sizes in the parotid gland. The one we are looking at now is known as the interlobular duct, as it is found in the connective tissue between lobules. The excretory ducts ultimately empty into the oral cavity via the parotid duct, also known as the Stenson's duct. Something you'll have to remember if you're thinking about the structure of the parotid gland in terms of salivons is that it is a very simplified model. In reality, they branch a little bit like a bunch of grapes. So what else is there to see in the parotid gland? Let's take a look at a couple of structures, which do not contribute to its action as an exocrine gland. First up, you'll often see adipose tissue intermixed with parts of the salivon. In this image, one of the adipocytes is highlighted in green. The adipose tissue is actually one of the parotid gland's identifying features, which helps you to distinguish the parotid gland from other salivary glands. You'll also find clumps of the same adipose tissue surrounding the external surface of the parotid gland, which is known as periglandular fat. In the connective tissue surrounding the parotid gland, we also find some periglandular lymph nodes. This is quite unsurprising, as the preauricular area, where the parotid gland is located, is quite lymph node rich. In close proximity to the periglandular lymph node, we can also see a branch of a peripheral nerve. That wraps up the parotid gland histology, but of course we can't forget our clinical notes section. The salivary gland tumours are found in all the major salivary glands, but are most common in the parotid gland. The parotid gland tumours usually manifest as swellings close to the ear and can sometimes be accompanied by xerostomia, which simply means dryness of the mouth caused by the blockage of the parotid duct. Numbness of the face may also occur if the tumour compresses the facial nerve, piercing the parotid gland. There are various diagnostic tools which can be used to identify a parotid tumour, including, but not limited to, X-ray, ultrasound, MRI and endoscopy, but the one we're most interested in is the biopsy, which produces a histological sample to be observed under microscope. What you'd see in the biopsy is quite interesting. The tumours are formed by some epithelial cells lining the duct system and myoepithelial cells which produce a cartilage-like matrix which the cells are suspended in. Quite different looking from the regular parotid gland tissue, if you ask me. A large portion of the parotid tumours are benign, and in that case, the excision of the tumour is recommended, although often the whole parotid gland is removed. With malignant tumours, radiotherapy is often recommended, in addition to the gland removal. Interestingly, chemotherapy has not been shown to be effective with parotid tumours. And that concludes today's tutorial. But let's have a quick recap of everything we learned today, shall we? We started by looking at the gross anatomy and function of the parotid gland. We saw it was an exocrine organ located anterior to the ear, which contributed to the digestion of carbohydrates. The parotid gland empties into the oral cavity via the parotid duct. We then moved on to the parotid gland histology, starting with the elements of the stroma. The dense connective tissue capsule covered the gland, while its extensions known as the connective tissue septa divided the gland into glandular lobules. Inside the lobules, we saw the functional unit of the parotid gland known as the salivon. It consisted of serous-secreting cells forming serous acini, which were surrounded by contractile myoepithelial cells and emptied into a system of ducts of increasing size. Here we looked at intercalated ducts, lined with simple cuboidal epithelium, larger striated ducts with simple cuboidal or columnar epithelial lining, and finally excretory ducts, lined with stratified cuboidal or pseudostratified columnar epithelium. Dotted around the acini and ducts, we found adipose tissue deposits, one of the identifying features of the parotid gland. We then quickly reviewed some structures adjacent to the parotid gland. Here we found some periglandular fat, a periglandular lymph node, and branches of a peripheral nerve. We finished up with a clinical notes section on tumours of the parotid gland. That's it, folks. Hope you enjoyed this tutorial. See you next time and happy studying!